Okay, so now we're going to have a look at what else causes differences in heat balance on the Earth's surface. We're going to look at the effect of different compositions of what the Earth is made of. And we can simplify that by just looking at the differences between land and water. We talked a little bit about this when we looked at specific heat, and that's one of the things that is different between land and water, but there are a couple of other things. Okay, so what's different between land and water that will affect the energy balance? One is the specific heat. So we know that water has a much higher specific heat capacity, so it's going to take in more energy to raise the temperature, so it's going to keep it cooler. Water allows more transmission of energy through the whole water body. All right, so because it's transparent, water is colourless, energy can move into a much larger mass of water compared to land, which is opaque. And so the energy, as it hits the land surface, can't move all the way through deep into the Earth's surface. It is concentrated just at that surface. Now again, we can go back to that beach example. When you're standing on a beach, the surface of the sand can be really, really hot and you're dancing around in your bare feet. But if you just dig down 10 centimetres or so, it's much, much cooler. And that's a good demonstration of the effect of transmission of energy. In water, the transmission goes right through, and therefore that energy is spread over that much larger volume of water. Whereas on land, it's concentrated just in that surface. So the surface heats up much more quickly. Another reason why water is colder at a beach than the sand is. Another reason is evaporation, or the latent heat of evaporation or vaporization, the technical term. So water is evaporating more because there's more water there. And so in that process of evaporation is taking in more of that energy. It's hiding it. It's not, you can't feel that energy anymore. Sort of get that? So the energy, the incoming radiation that the water is receiving, some of that is being used to evaporate off the water. And a significant amount. That's what gives us rain. Okay, so the oceans evaporate by absorbing some of that heat energy, storing it as latent heat. So it's not available as sensible heat. Whereas on land that has less moisture, because it's drier, you don't have as much of that occurring. So the energy that's coming in can be used to heat up the sand itself, and we can feel that as sensible heat. So it's another reason why sand is hotter than the water. And the other reason is that water moves. There are ocean currents, there are waves, and that circulation transfers the heat energy through that body of water, whereas on land, it can't. So it's, again, that incoming radiation is just used to increase the temperature of the sand near the surface that we can feel as sensible heat. All right, so it's these differences that actually drive our climate and our weather systems. Okay, so putting all that together, let's have a bit of a closer look at how temperature changes due to various features on the Earth. We're going to look at altitude, latitude, and something called continentality. All right, so we had a look at this briefly when we talked about seasons. So this is the effect of latitude. So latitude affects the level of solar input received by the Earth. Reflection increases with latitude because of that particular property of water. Therefore, that energy is not available to increase the temperature of the Earth. It's reflected back out into space. And the size of the footprint increases with latitude. The footprint is just the area over which a certain unit of incoming solar radiation hits, essentially. We talked about that before when we talked about seasons. So latitude means that the mean annual temperature decreases with increasing latitude. That's the effect of those two things, reflection and the larger footprint. That's why it's colder, one of the reasons why it's colder at the poles than at the equator. Okay. Now, you might say, well, all right, that's fine. So that means that there's, if we have a look at this diagram here, just ignoring seasons for the moment, at the tilt of the Earth, receives more radiation than the poles. And in fact, it's a negative. There's a net negative loss of energy at the poles and a net gain at the equator. So why doesn't the equator just get hotter and hotter and hotter, and the poles just get colder and colder and colder, and they both get eventually sort of thousands of degrees different? Well, the reason is that we have exchange of temperature via the atmosphere. Does it? Sure. But remember that water has a much higher specific heat capacity, so it's going to be able to transfer energy from one part of the Earth to the other. And if you have a look at these ocean currents closely, you can see that the warm ocean currents are heading towards the poles, and the cold ocean currents are heading away from the poles. And so that mixing helps to balance out the Earth's temperature regime or Earth's energy budget. Yes, it's colder at the poles, sure, absolutely, but it's not getting colder the whole time. And yeah, it's warmer at the equator, but it's not increasing. Why? Because some of that energy is being transferred away. And that happens all the time. Energy wants to move from somewhere where it's hotter to where it's colder. It's just the way energy moves. Okay. The effect of altitude. Well, we looked at this a little bit when we looked at the composition of the atmosphere. Now, we'll just ignore the layers above the troposphere, and just in our layout we know that temperature decreases with altitude. Now, why does that occur? Well, it's due to the decrease in pressure, air pressure. Okay, so when you're at the surface, you've actually got a whole lot of air, kilometres of air above you, and that's weighing down on you. That can be measured. But as you increase, you've got less and less air above you. And so the air is able to expand. And that expanding air cools it down. Okay? If you compress air, you'll actually increase its temperature. Okay? So you squeeze it together, you get friction occurring with those air molecules, and you increase in temperature. And on average, the decrease in temperature is about 6 degrees per kilometre. Now, that changes depending on where you are on the Earth's surface, and we look at that a bit later on too. So that's the effect of altitude that you've all felt when you go up a mountain. So the last thing we'll look at is continentality. Continentality just means the further away you are from the coast, the greater the differences in daily temperature ranges or diurnal temperature ranges and annual temperature ranges as well. Why is that? Well, it's the effect of the ocean that is keeping temperatures more stable. Because of water's high specific heat, its latent heat of vaporization, its mixing and its transparency means that it takes longer for water to heat up, and it also takes longer for it to cool down. So the variation is not as great as that sand surface, which goes up and down, because that incoming solar radiation is concentrated just on the surface of the sand. So on a broader regional scale, let's say Sydney or Melbourne, the temperature ranges throughout the year is not hugely great, okay? But if you go the same altitude and same latitude, you go to the centre of Australia, you can see that the differences are much, much greater. So let's have a look at Brisbane, which is a good one to look at because we can go at the same latitude well into the middle of the continent. So this is Brisbane's diurnal temperature range, okay? And let's compare that to, say, Alice Springs, which is around about the same latitude, but is much, much closer to the centre of the continent. So its continentality is high, it's much further away from the effect of the ocean. And you can see the differences. So that the ocean effect is keeping Brisbane's temperature regimes much more stable, whereas we don't have that temperature moderating effect of the ocean with Alice Springs. So it's another reason why you have different energy budgets affecting different temperatures on the Earth's surface.